Hey everybody, I want to show you how to graph quadratic functions. I've got 3 examples for you and a little bit of explaining to do before we start, so let me get started with that. So, that's my 3rd example. So here's the thing I want to explain. So a couple terms here with parabolas, so firstly, quadratic equations. Graph is parabolas. If you have like y equals x squared, you get something that looks like this. Positive x squared means it opens up, negative x squared means it opens down. The interesting points on your parabola are, there's at least one interesting point, which is the vertex. Vertex is the middle portion, or the middle point here of your parabola. And the reason it's interesting, well, there's a bunch of reasons it's interesting, but one of them is that the parabola itself is symmetric on both sides of this. So if you draw this line right here, it's called the line of symmetry. Is this guy right here, and it runs right down the middle of the parabola and through the vertex. For our purposes, we're only doing parabolas that go up and down. You can do parabolas that go sideways, but they're not functions, so it gets a little weird to deal with. So we're not worrying about those. So our line of symmetry always goes up and down, and remember that a vertical line is x equals some number, right? That's what the equation is. So it's x equals whatever the x coordinate of the vertex is. I'll return to that. The way I'm going to go about teaching you to graph a parabola is, I think, the most straightforward. There's a lot of stuff you can do. There's a form you can put in if you complete the square called vertex form. I'm going to ignore that. I don't care about that right now. The way I'm going to show you how to do this is, we're going to find the vertex. We're going to figure out if it opens up or down. We're going to find the y-intercept. And then we're going to find a corresponding point to the y-intercept, which by that I mean the one that is symmetric to it. So like over here, which is very easy to do because it's got the same y value, right? And you just have to figure out what the x value is. And then once you've got 3 points and you know which way it opens and what the vertex is, it's pretty easy to graph it, right? I'm not looking for like hyper precise graphing. I just want a nice sketch. And so, yeah, something like this is roughly what I'm looking for. So let's see how to do that. Oh, I guess there's one more thing I have to show you, which is what the formula for the vertex is. It's actually quite easy to find the vertex. If you have y equals ax squared plus bx plus c, so the most general form of a quadratic function, then the vertex, or the x coordinate of the vertex, is minus b over 2a. That's how you find it. If you're wondering where that comes from, it comes from the quadratic formula. That's the part that's left if you have 0 under the square root. So this is how you find the vertex. Yeah, let's do one. So I'm going to use this formula a bunch, and then we're going to find 3 or sometimes 5 points. Oh, we're also going to find the x-intercepts when it's relevant. Yeah, that's it. So let's go. Here's the first example. I want to graph that. So what I'm going to do is I'm going to start by finding the vertex. And my vertex, the formula is x equals minus b over 2a. Well, a is 1, b is negative 6, and do watch the sign. So this is minus 6 over 2 times 1, which is 6 over 2, which is 3. So the x coordinate of my vertex is 3, and if I want to find the y coordinate, I take the x coordinate and I put it back in the formula, because that's how you find the y coordinate for any point, right? And the vertex is just some point on the parabola. It's an interesting one, but it's still just a point on the parabola. So the way you find the y is by plugging in the x. Y is 3 squared minus 6 times 3 plus 3, which is, what's that, 9 minus 18 plus 9? 9 minus 18, not plus 9, plus 3. So it's negative 6. What's negative 6? So my vertex is 3, negative 6. Negative 6. All right. So once I have found the vertex, and I'm just going to glance at this and notice that the x squared is positive, so I know it opens upward. Once I've done that, what I like to do is go start graphing. I like to construct my graph and do my calculations kind of in concert, rather than doing all of one and then all of the other. I find it easier to know what to expect if I'm kind of graphing as I go along. So my next page is blank. So let's do this. So it was 3, -6. So I'm going to start here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Notice that I'm deliberately drawing it so that because I'm expecting it to open upwards because x squared is positive. Like, so that's how I'm constructing my axes. I'm deliberately making the bottom a little long. So 3, -6 was here. Here's my vertex. So I'm going to label it, and I know it's going to open upward, so it's going to look like this. So I'm going to label it below, cleverly leaving myself some room to expand upward. Now I already know what the line of symmetry is. It is this line. Now, the reason I care about that is the following. I need 2 more points in order to graph this, because you want to just get a sense of how wide it is. I already basically know what it looks like, right? It looks sort of, like a parabola that goes up from here. It's not that hard to figure out. They all kind of look the same. But what I'm going to do is I'm going to find the y-intercept. Now, the y-intercept is exceptionally easy to find. Always. It's always exceptionally easy to find, which is why I love doing it. Because the way you find the y-intercept is you let x be 0. When x is 0, this term right here and this term right here go to 0, and I'm left with 3. So it's always just the constant term is the y-intercept. So y-intercept . Zero, 3. All right, let's go put that on the graph. 0, 3 is here. Now, I want to find another point correspondingly on the other side of the parabola, right? I'm on the left arm currently, so I want to be on the right arm to find another point. And that's really easy to do because I just look at how far to the left or right of the line of symmetry I am and go that same distance on the other side. So I'm 3 units to the left over here, so I'm going to go 3 units to the right and maintain the same height. So right there. And that's enough information. I feel like comfortable graphing from here. So just a little tip when you're doing this, it's actually flat on the bottom and then curves up. So your parabolas will look nicer if you do this. Start by making it flat, and also they'll look nicer if you actually hit your dots. But whatever, close enough. There's my parabola. I'm basically done. Now, a thing that I will also ask you separately for is to find the x-intercepts, because those are also interesting points some of the time. Like we learned in the last topic that those were the solutions to this, in this case, x squared minus 6x plus 3 equals 0. So let's find those. And that's relatively easy to do, because what we're going to do is we're going to find the solutions to, we're just going to set y to 0. So it's going to be x squared minus 6x plus 3 equals 0. And I am going to just use the quadratic formula for that. So I'm going to set y to 0 to find the x-intercepts, and we're going to get 0 equals x squared minus 6x plus 3. And I know that x is minus b plus or minus the square root of b squared minus 4ac all over 2a. And we'll just kind of jam the numbers in. So we've got minus b is 6 plus or minus the square root of b squared is 36 minus 4ac is 12 all over 2a, which is 2. So I've got 6 plus or minus the square root of 24 over 2. Now, you might recall that I mentioned that you can simplify your square root here. So the biggest square that goes into 24 is 4. So this is 6 plus or minus the square root of 4 times 6 over 2, which is 6 plus or minus 2 root 6 over 2. And because the 6, where's my mouse pointer? This 6, this 2, and this 2 all have copies, all have a 2 in them. I can factor that all out and cancel. And so I end up with 3 plus or minus root 6 all over 1. I'm not writing the over 1. So I have 3 plus root 6 and 3 minus root 6 are my x-intercepts. So we'll 3 plus or minus root 6 are x ints. I'm out of room here, but there you go. We found everything. Great. That's all there is to it. Now, in general, when you are graphing parabolas, you basically want to find the vertex and a couple of points, at least one point on each side. And that'll usually do it for you. That's pretty much what you want in order to graph a parabola. Not looking for super precision. If I wanted super precision, I'd have you do it on a calculator. And speaking of that, I did it on Desmos. So let's go look at Desmos. Where's my Desmos? There it is. X squared minus 6x plus 3. Bam. That's pretty much what I had. Just drawn better. So yeah, there you go. Not too bad. All right, let's go back to do the next example, which you can see what it is. All right, I want to do minus x squared plus 6x minus 9. So I notice right off the bat that this has a minus in front of the x squared, so I know it's going to open downwards, or it's going to be an umbrella rather than a cup. And I'm going to do exactly the same things we just did. I'm going to start by finding the vertex. So we're going to have x equals minus b over 2a, which is minus a minus 1. Nope. That's a. Minus 6 over 2 times minus 1. That's what I meant. Did I make this one 3 again? I did. Well, 3 minus 6 over minus 2 is 3. I should have done that. So the y is what I get when I plug 3 in. So y is minus 9 plus 6 times 3 minus 9, which is 0. Well, that's interesting. All right, so my vertex is 3, 0. Let's see, vertex 3, 0. All right, great. Let's go get the graph started. Come on, there we go. So I know it opens down, and I know my vertex is on the x-axis. Actually, is 3, 0. All right, so 3, 0 is right here. I know it opens downward. I've got my line of symmetry goes right there. Okay, so I know it's going to open downward from here. So I pretty much want to know what it looks like already. Let's go find the relevant points. And that's not the right button at all. There we go. Let's go find the y-intercept. So my y-intercept is, well, I put 0 in for x and I get y equals -9. 0, -9. Good. That goes nicely with what I was expecting to see. I didn't draw my axes long enough. 2, 3, 4, 5, 6, 7, 8, 9. Sure, that's fine. That seems fine. So I got a point over here. And I'm going to find the corresponding point on the other side, right? I went 3 to the left, so now I'm going to go 3 to the right of the vertex. And we got this point right here. And there's my parabola. So we're going to start out flat here. It's not terrible. Now I could spend some time finding the x-intercepts, but I don't really need to do it algebraically. I already know what they are, right? Or what it is. There's only the one. It's right here. There it is, 3, 0. The intercept is also the vertex in this case. It's not usual, but it does happen some of the time. That's it for that one. Let's do another one. Actually, before I do that one, let's pop over to Desmos. I'm feeling good about this graph, but let's see what it looks like. Desmos agrees. Fantastic. Just like I had it, y-intercept -9. Right here at 3, 0 is both the vertex and the x-intercept, and we're good to go. Fantastic. Let's go look at this guy right here. All right, so I'm graphing this. This one's a little bit messier, so let's find the vertex. Vertex is x equals minus b over 2a, which is -4 over 2 times -3. So that is 4 over 6, which is 2/3. All right, well, this one's going to be messier because now I got some work to do, right? I have to put 2/3 in for x here, which is kind of a pain. But what are you going to do? Yeah, -3 times 2/3 squared plus 4 times 2/3 minus 2. All right, so that's like I said, a little bit messier. So we're going to get minus 3 times 4 over 9 minus 3 times 4 over 9. Well, that's nice that the 3 and the 9 cancel. Plus 8 over 3 minus 2, which is negative 4/3. 4/3 plus 8/3 minus 2, which I'm going to write as minus 6/3 because I need a common denominator anyway. Right, so I've got 4/3 minus 6/3 is minus 2/3. Negative 2/3. Oh, that's nice. All right, so my vertex is 2/3, negative 2/3. All right, that one was a little bit messy. Now, luckily, the y-intercept, no problem, negative 2. Y-intercept, 0 for x and negative 2 for y. So let's go get a graph going here. All right. It occurs to me that I could probably pre-draw these so you don't have to watch me do it, but that's okay. I'll bore you. You can just watch me on double speed. Make me all chipmunky. All right, so I've got vertex is 2/3 negative 2/3. So that's a little bit less than 1, comma negative a little bit less than 1. Something like that. That's reasonably close. There's my line of symmetry, or it would be a line if I could draw straight. All right, 2/3 negative 2/3, and the y-intercept is 0, negative 2, 0, negative 2. All right, so I need to find my corresponding point here. So I've gone, so the x coordinate here, let me draw this. This is 2/3, negative 2/3. Is that point right there. The y-intercept is at x equals 0, so I'm 2/3 to the left of my vertex. So that means that my corresponding point should be 2/3 to the right. So I'm going to add 2/3 to this, and you get 4/3. And that's going to be where my other point is, the x coordinate of my corresponding point, which is here-ish. Not here, but that's where it is on the x-axis. And then the y coordinate is the same. So something like this. So yeah. And I can tell, because I know this opens down, that it opens down and the vertex is already below the x-axis, that there are no x-intercepts. So I could go searching for them, right? I could plug it into the quadratic formula, but I'm going to get complex numbers. It's going to come out to be no real solutions because there aren't any. I already know that's going to happen, so I don't really need to go through the motions of doing that. So no x-intercepts, no x. And I'm done. There you go. So that's graphing parabolas. Find your vertex. Notice if it opens up or down. Find your y-intercept. Find the corresponding point to the y-intercept. And then find x-intercepts if there are any. And that's it. That's how you do it. So it's kind of a lot. Like, it's a lot to remember, but each step is actually pretty easy. Yeah, each step, that really is what I want to say. It's a lot of steps, but none of the steps are hard. They're all fairly easy. Sometimes it gets a little messy if you get fractions, but that's kind of as bad as things get. It's really not too bad. So let's go check to make sure that my graph that I've made, this guy right here, agrees with what Desmos said. Desmos, what do you think? Oh, it agrees. Fantastic. Looks like I'm doing a good job here. Yeah, that's really all I want to say about this. So one way you can practice graphing parabolas is you can just kind of pick random numbers for A, B, and C, right? I could do like y equals 2x squared minus 7x plus 4, right? And I could see if I could graph that. That says, and you want to know if it's right, put it in Desmos, see what Desmos says. And yeah, that really is pretty much all I want to say about graphing parabolas. So I'm gonna go ahead and stop the video there.